Welcome on board the Grand Evans Express. The members of this group, Huan Park, Sophia Bowser, Maya Lee, and Sabisha Chinasum, will be your hosts from Eisenhower School. Let's get started.
Solar energy, which powers a solar car, is an eco-friendly energy source. Solar cells, which are made up of the semiconductor silicon, have the atoms inside connected to one another with strong bonds. However, when the photons and sunlight strike the cell with enough energy, the electrons are knocked from their bonds, leaving holes in their place that are not able to move. Then the holes and electrons are attracted to the two different types of silicon in the cell. This allows the electrons, now isolated, to be able to flow through an outer circuit, be put to work, then return to the cell. Therefore, solar energy is reusable, renewable, and eco-friendly, showing its benefits as an energy source. However, because it is unevenly distributed and is inconsistent depending on the weather, it still requires more research.
We experimented with this energy on our car. We first tried it in cloudy weather. However, although there was some sunlight, the car didn't move because there wasn't enough sunlight. We then tried it in sunny weather with the panel just facing up. However, the car went slowly because it was not getting enough solar power. Lastly, we used wires to hold and tilt the panel towards the sun so that the panel would get as much sunlight as possible, which made the car go faster, so we settled with this choice.
This was our final prototype.
Our chassis is a water ball. We originally had an idea of using balsa wood, but we changed our idea after we thought about how a water bottle is aerodynamic, making go faster, and is upcycled. For the design of our chassis, we chose a crayon.
We poked holes on the sides of our chassis for our axles to go through. Our team hot glued straws through the holes to reduce friction and to make sure our car didn't swerve to one side. We added rubber bands to add friction so the wheels would grip rougher surfaces. Our team had first started with the gear ratio of 3:6, with 60 as the driver and 30 as the driven, which means that it is more speed than torque. However, because it needed more torque, we came up with the idea of holding up the motor and the gear using popsicle sticks as a bridge through the middle of the bottom. Then we cut a thin slit in the bottom of the chassis, allowing space for a bigger gear to fit on the axle. Now that there was enough space, we tried out several different gear combinations and eventually decided on the gear ratio 4:2, giving the car the ability to go forward with a heavy weight.
Electrical connections also contributed to the speed of our car. We stripped wires and used alligator clips on them, securing them with electric tape to ensure stable connections. We also added a button to turn the motor on and off so that we would be able to connect the car easily without harming the parts inside. We then taped the battery pack inside the chassis so it would be easily detached in the case of an outdoor race.
The solar panel holder was made from wires from an old project. This material is long-lasting and it can be used again. We used an already bent paper clip as our guide wire connection. This is durable and it can be used again by bending it into a shape that makes it useful.
Thank you for listening to our presentation. Vote for Evans Express. Bye.